Hello friends, myself R.D. Mahajan presenting my video on two-dimensional heat flow equation, also called as Laplace equation. For that, consider the flow of heat in a metal plate of uniform thickness as shown in the figure. Therefore, this is that metal plate of uniform thickness. Consider a rectangular element PQRS with edges delta x and delta y as shown in the figure. The coordinates of P, x, y, coordinates of Q, x plus delta x and y. Therefore, the length of this PQ is delta x, a very small quantity. Coordinates of R, x plus delta x, y plus delta y. Therefore, the length of this RQ is delta y. And the coordinates of S are x and y plus delta y. Therefore, the edges of that plate are delta x parallel to x axis and delta y parallel to y axis. If the heat flow lies in xy plane, then that flow is called as two-dimensional. This is xy plane, XOY, or we call as xy plane. Then that flow is called as two-dimensional. And equation of that two-dimensional heat flow is dou tu by dou x square plus dou tu by dou y square equals to 0. This is also called as a Laplace equation. Therefore, after knowing what is meant by Laplace equation, we try to find out its solution by applying method of separation of variables. Let the equation of that Laplace equation be dou tu by dou x square plus dou tu by dou y square equals to 0. As the derivatives are obtained with respect to x and y, let the solution be u is equal to capital X into capital Y be the solution of equation 1, and we call this as equation 2. U is equal to x into y, capital X into capital Y. Then differentiating 2 with respect to x twice. Differentiating 2 with respect to x, we get dou u by dou x is equals to x dash into y, keeping y constant. Again differentiating, we get dou tu by dou x square as x double dash, next derivative of x dash, into y. Then differentiating with respect to y, differentiating equation 2 with respect to y, keeping x constant, we get dou u by dou y as x constant outside, derivative of y is y dash. Again differentiating it, we get dou tu u by dou y square as x into y double dash. Substituting these two values in equation 1 becomes put it in equation 1. Therefore, dou tu by dou x square is x double dash into y plus dou tu by dou y square as x y double dash, and that is equals to 0. This is nothing but x double dash into y. Transferring this term to right hand side, we get minus x y double dash. Then separating the variables, we get x double dash upon x is equal to minus y double dash by y and equal to, then equating first with last we get x double dash by x is equals to k, and second minus y double dash by y equal to k. We get x double dash is equal to k into x. Then transferring that to left hand side we get x double dash minus kx equal to 0. In symbolic form it becomes d square minus k into capital X is equals to 0. We get second order linear differential equation which we have to solve for capital X, and from this we get y double dash is equal to minus ky. Then transferring this to left side we get y double dash plus k into y is equals to 0. Again in symbolic form it becomes d square plus k into y equals to 0. Therefore, this represents another linear differential equation in terms of capital Y. Means from this we require to obtain the value of y, and from this we require to find the value of x. And whatever that value is, if we put here in equation 2 to get the required solution. From this equation we get the auxiliary equation as d square minus k equals to 0, and from this we get the auxiliary equation as d square plus k equals to 0. And depending upon the values of k, we have to discuss three different cases. Case number 1, if k is negative, that is, suppose k is equals to minus value, here in this we get d square minus of minus n square, it becomes plus n square is equals to 0. Solving it for d, we get d square is equals to minus n square, d is equals to root of this minus n square as plus minus ni, and from this we get d square minus n square equals to 0, d square is equals to n square, d is equals to, taking square root, we get two values plus minus n. And when we have imaginary roots, the solution is capital X is equals to, it is alpha plus minus I beta. Here alpha is 0, therefore e raised to 0 x in bracket c1 cos of nx plus c2 sin of nx as the value of that capital X. Then from this we get roots are real and distinct, two different roots. In that case, capital Y is equals to, we have C3 e raised to minus ny and C4 e raised to ny. And therefore, substituting these two values in that equation 2, we get u is equals to, therefore, it is capital X means C1 cos nx plus C2 sin of nx, and capital Y is C3 e raised to minus ny plus C4 e raised to ny. This is one of the possible solution when the value of k is negative, case number 1. Then we discuss second case when the value of that k is 0. Then if we put that value of k as 0, we get d square is equals to 0, and for the second we get d square is equals to 0. Here the roots are 0 and 0, two real and equal roots, and for the second also we get d square is equals to 0 and 0. Again real and equal roots. When roots are real and equal, we get the solution for capital X as it is C1 plus C2 x into e raised to 0, that is 1, and for y we get as C3 plus C4 y, and then substituting these two values in that equation 2, we get u is equal to capital X into capital Y. X is C1 plus C2x and y is C3 plus C4 y. This is another possible solution. Case number third, if the value of that k is positive, suppose k is equals to n square, then substituting that value here in this, we get the first auxiliary equation as d square minus n square is equals to 0. That is d square is equal to n square. Taking square root, we get d is equals to plus minus n, two different and real roots. And when roots are real and different or distinct, we get capital X as C1 e raised to minus nx plus C2 e raised to nx as the value for that capital X. Then substituting k is equal to n square in this equation, we get d square plus n square is equals to 0. Nothing but d square is equals to minus n square. Taking square root, we get d is equals to plus minus n I, imaginary roots. And whenever we have imaginary roots, its solution is, and here this time for y, it is e raised to 0 y C3 cos ny and C4 sin ny. And therefore that solution is u is equal to x into y, capital X into capital Y. Value of x is C1 e raised to minus nx, C2 e raised to nx, multiplied by this value of y, it is C3 cos ny, C4 sin of ny. Therefore, this is the third possible solution. Therefore, I will combine these three possible solutions in one place. The first case, when the value of k is negative, at that time we have the solution as u is equal to C1 cos of nx plus C2 sin of nx multiplied by C3 e raised to minus ny plus C4 e raised to ny. Second possible solution, when k is 0, at that time we have C1 plus C2x multiplied by C3 plus C4y when k is equals to 0. This is second possible solution. And the third, when k is positive, at that time we have C1 e raised to minus nx plus C2 e raised to nx multiplied by C3 cos of ny, C4 sin of ny. When k is positive. Therefore, we have three possible solutions. First one, second one and third one. And depending upon the given conditions, we have to use either the first one or the last one. Then we have to consider one as the solution, one of that as the solution, which will satisfy the boundary condition of the given problem. Therefore, depending upon the boundary conditions, we have to consider one of them as the required solution of that given Laplace equation or given two-dimensional heat flow equation. In my next video, I will discuss one problem based on this two-dimensional heat flow equation. If you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you.